Alrighty. Shh. Hey, Mitchell, keep it that way. It's the first thing they're going to hear when they come back and watch that video. This class is quiet because O'Neill's not here. No, it's quiet because for some reason you kept your mouth shut for a little bit. And now that'll be the first thing they hear when they go back and watch it. 9-7, solving linear nonlinear systems. Linear systems are what? I know, this is a blast from the past.
They make a line.
How many lines?
One.
No, systems.
Multiple.
Two or more.
Multiple means two or more.
Yeah. So
Whatever. Technicalities. 2 or more. Alright, now, that's lines. Nonlinears are what? Everything else that we've done. Yeah. Quadratics. Parabolas. Circles. Ellipses. Hyperbolas. They could all be there. Yeah, it is fun. I think so. So here we go. A system of equations. Alright, now we're going to start with linear, nonlinear. Okay? Whereas one equation is linear, one is not. Alright? So one is linear, one is not. When that's the case, you have 3 possible outcomes on solutions. You could have 0, 1, or 2. Graphically speaking, they could look like this, where the two don't intersect at all. Could have one like this, where they intersect once. Or you could have one like this, where they intersect twice. Max.
Isn't, you said two. I don't know. But isn't that a segment outline?
Which one? This one?
Middle line.
That's actually an absolute value graph. This V
I
right
got
here,
you.
that's an absolute value, yeah. Your one solutions, to be honest, on these, they're a little rarer than most. Typically these go 0 or 2. But not always, obviously. They could go however. Alright, but graphically speaking, that's what they look like. These you can solve by using your algebraic methods. Which are what when you solve
System of
systems?
equations
When you,
where like you equal each other.
when you solve systems, the big 2 to solve these are what? Elimination and substitution. You're going to use both today.
I like it.
Okay? And not really because one's an easier than the other, but because it's kind of necessity to do it. Okay, so you're going to use both for sure. All right. Everybody ready for your first one? Okay, let's go. Number 1. You have 9x squared plus 25y squared equals 225. You have 10y plus 6x equals 6. Okay? Bless you. Now, what I do, when I see this, I look at it, I notice that I have you have a nonlinear with a linear, right? And typically when that's the case, when you have one of each, like think about it with elimination. You can't get rid of x squareds with x's. They're not like terms, right? So to try to eliminate those two would be pointless. So it's not necessarily that you want to use substitution, you have to use substitution. Okay? Now, obviously you could go either route with which variable you solve for. I, for whatever reason, solved for y when I wrote these notes out, so I'm just going to do it here again. When you solve for this y, you get it to be y equals negative, I did decimals here, 0.6x plus 0.6.
What, Mr. Moore?
How did you get that?
I know. It's late in the year. I'm getting weak. I know. My teacher powers have almost drained.
Dang.
I know.
That's an all time.
Subtract 6x over, divide by 10, right? 0.6 negative 0.6x plus 0.6. Right? This guy, solve for y. Okay?
So you're just going to square that.
Now you're going to substitute this quantity in for this y.
Ooh.
Okay?
Ooh,
That's a gross.
It is going to be gross.
That's really
Okay, so 9x squared plus 25 0.6x plus 0.6. That quantity needs to be squared, and the 0.6 needs to be negative. There we go. Equals 225. All right. Now, at some point in your life, I gave you something that might help you here.
Quadratic.
Nope.
Oh, that's your square.
Yeah, it's a squared binomial. I gave you a squared binomial program. You're welcome. I actually, when I looked to make these videos, I actually looked at this problem and I saw that and I go, I wonder if I can write a program for binomial squared so they don't have to mess with negative 0.6 times negative 0.6 and that really screwed that up. I bet you I can. Oh, look, I did.
Which is that one?
Which is the one that says square binom. So you get 9x squared plus 25 times the squared out quantity of 0.36x squared minus 0.72x plus 0.36,
Oh, snap, it worked.
which all equals 225. All right. Now, clearly you can understand why I went to decimals here.
Yes.
Okay. Honestly, I love fractions. They're my faves. Decimals are the way to go on these. Okay? Because fractions with all this would be,
Right.
all right, yeah, a little nasty. After this, guys, it's really just kind of going through the motions of doing your normal solve, okay? From here, it's all about your algebra, distributing correctly, combining like terms, getting it down to a quadratic that you know how to solve. Because obviously it's going to be that because we have x squareds in there, or at least that's what it looks like it's going to be. But once you understand the notation and the setup of everything, it's no different than anything else. It's just uglier.
So they're all going to be like.
Yes, these are going to be nasty. I'll tell you that right now. These will be nasty. Okay? But next up, you just distribute, right? Distribute that 25. So 9x squared plus 9x squared minus 18x plus 9 equals 225.
Wait, how did it work out nicely? Do they just multiply out to be nice?
It's lit, ain't it?
Yeah.
Mr. Mormon just used lit in class. Oh, jeez.
That's my
It must be May.
workout, yeah.
It's going to be a quadratic, right? So when it's going to be a quadratic, we need to make it equal 0. So I'm going to combine my two 9x squared terms, subtract the 225 over. All right, which gives you 18x squared minus 18x minus 216, which equals 0.
Factor out
The nice part is everything's divisible by
18.
18, which leaves you with x squared minus x minus 12 equals 0. And that guy factors x minus 4, x plus 3. Swing them to the other side. X equals 4. X equals negative 3.
So now you're testing for work.
Okay.
And then 5 minutes.
So that's the solve. That's the solving for the system for your x's. Okay. Now, how many different x's do you have? 2. So we'll go back to how many solutions you could possibly have here. How many solutions are you going to have?
2.
2, because you have 2 different x's. Okay. So think about this graphically. We have what looks to be a circle and a line. So that line intersects that circle in how many places?
2.
2. Those 2 places are 2 totally different points. Yes?
Yep.
Okay, so that means you're going to have 2 ordered pairs as your solutions. One of them is going to have the x coordinate of 4. The other one's going to have the x coordinate of negative 3. The only thing you have to do now is find their corresponding what?
Y.
Y's. And you would do that by taking 4 and plugging it in, getting that y. Taking negative 3, plug it in, get that y. Okay, so now you have to go back and do it twice. All right, so y equals negative 0.6 times 4 equals 6. I don't know why I put equals twice. That should be a plus. There we go. Which will end up, if you're doing your calculator, giving you a negative 1.8. And then you go the other way. Y equals negative 6 times negative 3 plus 6, negative 0.6, there we go. Which will give you y equals 2.4. And then you write your order pairs corresponding. Okay, so you know when you did your baby systems, you know you just put them in alphabetical order, x, y, x, y, z, whatever. Here you got to make sure you match them up with what they go with. Okay, so we have an x of 4, and when we plugged in 4, we got the y coordinate negative 1.8, and when we did negative 3, we got 2.4. And those are our solutions. Okay, so just a quick comment about this one. If you want to make life easier on yourself, if you look at this here, okay, you have 3y plus x squared minus 4x minus 17 equals 0. You have 3y minus 10x plus 38 equals 0. Your bottom one obviously is a line. Your top one is a what? Not a line. Very good. It's a parabola. It's got 1 squared, 1 not.
Question: if you could just make them both equal to 3y, can you make them equal to each other?
You can.
Would that be easy?
Um,
yeah, it would be just.
Yeah. Because then you could just substitute in for.
Mm-hmm.
Yeah, you could do it that way. You could get it to go the other way. The thing I was going to say was, and it kind of goes with that. The way I did it on my notes, I made this one equal 3y, and then when I did that, I had 10x minus 38, and I just substituted that straight in for that 3y, right? Because as long as they're equal, they can go in for each other, right? 3y equals 3y is the same as having y equal y, right? Make sense? Why?
Mm-hmm.
Okay. So it doesn't matter as long as you figure that out, okay? Basically what I was going to say with this one was don't solve for x down here. See how, because you had to square it then, and it saves you a mistake maker, all right? If you want to do this one eventually, like I said, just to make sure we get through all the harder ones, which are your non-linear systems. This one's is negative 11, 49.3 for forever, and 5.4. What? Oh, that's that one. All right, if you want to go back and look at it and try it, because I know some of you have some gumption about you to do things like that. Some of you don't. So, all right. Any questions on linear and non-linears? Alrighty.
What is that number? Is that a 3 or a 5? 49 point something?
49.3 forever and ever. Amen. That's a 3. That's clearly a 3.
Or
sideways,
that was like a 5
or gravitating M. One of the two, but it's definitely not a 5.
Alright.
Because clearly this part of the hat goes on too far, and this part of the, where you connect the hat
I was like, that's not even a number.
goes this way and down. It doesn't go up. If it went
they were
up, I
connected.
could see it.
Oh,
So,
wow.
the people that are going to go back and watch this are going to be like, what the heck are they talking about?
I was never recording.
I was recording.
Oh, wow.
Oh, well. Moving on. All right, let's get a little nastier. This is where you can have anything, and I mean anything. It could be 2 ellipses, it could be a circle and a parabola, it could be a parabola and an ellipse, it could be a hyperbola and a parabola, it could be anything. Which means your solution set ranges for anywhere between 0 to 4. Now you could have 0 points that intersect, you could have 4 points that intersect. Okay? You won't go more than 4. Okay? I'm trying to think, I don't think it would ever go more than 4. Okay, but there's an example, if you look at that pretty picture, there's an example of each one graphically, case-wise, of why it works the way it does. Okay, you could have a parabola stuck between a hyperbola where they don't intersect at all. Parabola going off of one point of the circle, the vertex intersecting. You could have a parabola and an ellipse, circle and a parabola, 2 ellipses, circle, all different kinds of stuff. Where you care about is where they intersect at. Alright. Now, whenever you have these systems, you are definitely going to want to use elimination. Alright, you don't want to try to substitute these. You want to do elimination because what do all of these, now think of these graphs, now think of their equations. They all at least have one term in common. Okay? It'll be either an x squared or a y squared. All of them. Okay? They will all at least have that much in common, which makes elimination a lot more feasible and a lot more realistic. Okay? So we're going to start off with a baby one.
What is it?
It's a baby one. Look at it. Oh, it's so cute. Okay, x squared plus y squared equals 45. And then y squared minus x squared equals 27. Okay, first thing they try to do is trick you and make you think, oh look, it's already lined up, but it's not. Okay, so make it lined up. I'm going to move like this, y squared plus x squared equals 45. Y squared. You can look at it and get it. You can look at it and get there if you want to. Okay, I don't care. Just I'm doing it for those that aren't as advanced as you two. Okay, Caleb. Oh, I got you. Okay, I got you. Alrighty. Okay. Now, obviously, your x's are going to cancel. Your x squareds. So you're left with 2y squared equals 72. And now you'll go down and solve for that y. So divide by 2. Y squared equals 36. Not 6. There we go. Okay. And the square root of 36, when you have it in an equation, gives you y equals plus or minus 6. And that plus or minus is definitely important here, people. Okay? Because that's where you're going to get your 4 solutions from. Alright? That's where they're going to come.
Okay, how come sometimes when we're doing square roots it's not plus or minus?
It depends if you depends if you introduce it or if it's there already.
See, my question on that is, why would it matter in the equation if it's, because either way when you square it's going to be 36 positive.
Very good.
So that's why the answer can be negative and positive.
Or like how many solutions, so it's kind of like
So you still have 4 solutions. Okay. That's why. Alright. Because you got to do it twice then. Okay, makes sense? Alright, and then from there, yeah, like I said, just plug it back in. Take the positive one if you want to. Alright, so then you go in. X squared plus, do positive 6 squared equals 45. 6 squared is 36. This is where we're getting to the point where I can start seeing some step skipping. Alright, if you don't want to write out that that's 36 and just go straight to 45 minus 36, I am perfectly okay with that. X squared equals 9, which gives you x equals plus or minus 3. And then go with it with negative 6. I'm going to do that up top over here. I know I'm going all over the place, but that's kind of how the day goes. X squared plus negative 6, colon A squared equals 45. X squared equals 9. X equals plus or minus 3 once again. Okay? And that is common. Alright, that is common, but you got to make sure you get all 4 of those points. Okay? Because you had 2 different y's, right? You had y of 6 and a y of negative 6. When you plugged in your y of 6, you got 2 different x's from there, which are what? 3 and negative 3. So when you had a positive 6 as your y, you had 2 answers, or 2 solutions, 3 and negative 3. When you plugged in negative 6 as your y, you also had 2 different solutions, which were 3 and negative 3. Okay.
just like all the different combinations. It's not all that easy.
Wouldn't it be nice?
Yeah.
Any questions? Okay. That one. So I'm still going to eliminate this one. Alright? Which means I'm going to do top minus bottom. So I'm going to go like this. X squared minus x squared gives me no x squareds. Yay. Y squared minus 0 y squareds in this one gives me y squared. No y's minus 3y gives me negative 3y's. 8 minus 10 gives me negative 2. Right here was where I thought the rookie mistakes were being made. Okay, be careful with that if you're going to subtract them, because that is what you should do to get rid of these x squareds. Make sure you put this negative to the other two as well. All right. From there, you have a nice little quadratic equation. So add 2 y squared minus 3y. Whoops. All right. And if factoring is not your strong suit, guys, use your quadratic formula program. Okay, I gave it to you. All these programs I gave to you so you can use. All right, I'm not gonna shun those that use them because, well, that's why I gave them to you, for you to use them. So if you can't factor fast, hit your ABC, put it in, skip over discriminant, get your solutions, move on. Okay. So you have y's of 1 and 2. Take them into one of your equations, plug them in. So let's go x squared plus 1 squared equals 8, which means x equals x squared equals 7, which means x equals plus or minus the square root of 7. And then go the other time. X squared plus 2 squared equals 8, which means x squared equals 4, which means x equals plus or minus 2. Okay, so as you can see, these won't always be all 4 of your coordinates all the same all the time. Okay, so you just have to be careful. All right, bless you. All right, so right after solutions, you should have one of, let's see, when you plugged in 2, you got 2 and negative 2 for your x's. And when you plugged in the 1, is where you got the square root of 7. Up to you, because on my notes I have this as decimals, actually.
Wait.
Okay. Here's the thing. All right. If you leave them as the square root of 7, that's fine. If you put that as a decimal of 2.65, that's fine. But if it's like, say, it's the square root of 48, you got to simplify. If you're gonna leave it like a square root, you got to simplify the square root. Okay.
So it's still plus or minus, even though you never even took the square root away.
Correct.
Weird.
And false.
Is there a negative in front of this third two?
Yes. Then the x one right here. Yeah, there should be.
Numbers are interesting.
Okay. Everybody good?
Yeah.
Not terrible, but a lot of work. A lot of writing. A lot to keep track of. All right. Last one. There you go. Have at it. Here we go. Yes, the way you guys were talking about doing this is how you want to do this. 3x squared plus 4x, or 4y squared rather,
Bold strategy.
equals 48. It's a bold strategy, Cotton. Let's see if it pays off for him. Multiply this guy here by 4. If I could draw a 4 today. There we go. Alright, so then you get 8x squared minus 4y squared. Leave me alone! Equals negative 4. It's a square, you just can't tell.
It's a square.
Yeah,
Where?
right there. Kind of. Close enough.
Norman, that's a 2 squared.
Wait, what? What are you talking about?
Huh.
What is that?
Thanks for catching that. That was a great throw. 11x squared equals 44. It's a soccer ball, not supposed to spiral. X squared equals 4, so x equals plus or minus 2.
Well,
Alright.
yes.
What's wrong, Rachel?
Jansen, you okay?
No.
Alright. Moving on. Now, x equals 2.
For a second, I didn't have the
Yeah.
one negative, and I kept getting like,
Alright, so now when you plug in 2, here's what I kind of start setting these up as. I start splitting them off, doing x equals 2 in one spot. So 2 times 2 quantity squared minus y squared equals negative 1. Just to kind of keep things in order, so that way you know which one you're working with, so you don't forget. A little more organization. So 8 minus y squared equals negative 1. However you want to do it, somehow, some way, it should end up being y squared equals 9, right?
Which is plus or minus.
Which ends up being plus or minus 3 for y.
Wow. See, this should be like the whole test, actually. I understand.
Go the other way. X equals negative 2. Get 2 times negative 2 quantity squared minus y squared equals negative 1, which gives you 8 minus y squared equals negative 1, which gives you the same thing, y squared equals 9, y equals plus or minus 3. So you have an answer smack down in the middle. Oh, that was a beautiful parenthesis. I have no idea. 2, 3, 2, negative 3, negative 2, positive 3, and negative 2, negative 3.
I don't have time to like screenshot it. Like I have my finger on the